going to take the normal Terminator breakup, and it's going to take all the brush textures that I've been using for the foundation for everything, mixed together, some with world space and not, so that I have a strong, relatively powerful material that I can use, still compiling, that I can use before I do my compositing. Make sense?
Totally. Yeah. That was really complex. I'll probably pay for a class on this, but this is like genuinely impressive. And we had this very similar idea to use the Fresnels to sort of break up the silhouette of the object. Except we didn't just straight up didn't know how to implement it along with the material. So seeing that you're using the vertex color, like vertex painting to get the colors, and then also, can I ask what exactly is a Terminator? Never heard that term before.
Shadow Terminator is basically the concept of. Let's just quickly Google that up. Shadow Terminator. The Terminator is where, when you look in a sphere, you have the light side and then you have the dark side. Basically, maybe I'm using the wrong terminology.
Wrong terminology. Yeah, these are still pretty
Terminator.
Cool, it's just Shadow the Hedgehog.
Oh man, that's good. Yeah, here it is. Here it is.
There it is.
So here you have what I call is you have the highlight, right, which is the direct light, and then you have your midtone, which is the gradient of the indirect light, and then you see this line along the sphere, semicircle.
Yeah.
This is what I would call the Terminator. This is where the light terminates and the shadow begins on the object. Yep.
Okay.
So that to me is the Terminator. Notice that the sphere is perfectly smooth. So in my case, I want to break up the normal, so it breaks up this Terminator on the shadow. Maybe my terminology is not correct, but if I repeat it enough, maybe it'll become official. Who knows?
No, I think I understand it better. Yeah. Okay. So you're like breaking up the normals. Yeah.
Yeah.
Let's say you want to animate this model with this specific shader. Would you be able to animate the brush strokes as well? Because technically, if we like trying to emulate a frame by frame, those brush strokes wouldn't be the same throughout every frame. They'd flicker and change.
Because I used UVs, they are stuck to the mesh. So for example, if I deform his nose, for example, notice that the brush strokes are going with it. They're deforming based on how I want him to be, because I'm using UVs.
Okay.
So if I want to animate the brush strokes, like the direction of it, then I can use flow maps to drive the direction, or I can just change the UVs. So for example, if I think the brush strokes on this beard are too small, for example, I can go to my UV editor and go into back into rendered mode. And if I think the brush strokes are too small, then I just select everything and I scale it bigger or smaller to the size that I think should be coherent with the world. I don't have to be like super specific, but now like if I zoom out a little bit, the brush strokes on the beard are now much bigger because the UV texel density is a lot smaller. As you can see, it's based on the UV.
So with this sort of thing, if let's say you wanted this model or you wanted to make an animation using this, then couldn't, instead of using a static UV, you could possibly use maybe an image sequence where the brush strokes change frame by frame?
Yeah, I could for sure.
So
I mean,
have a different look every frame?
Yeah, in this case, I don't want it because it's a bit tiring to watch. That's one thing I noticed is When it comes to coherent stylization with Painterly, coherent stylization is the official term that you're looking for. If you're looking to Google for more material or papers or SIGGRAPH stuff about this, search for coherent stylization. The key problem with Painterly with digital animation is that it jitters too much. And if you're watching this for more than a few minutes, the viewer can get very tired and it can pull the user away from the story. If you have some coherent stylization with a little bit of jitter, then it becomes a little bit more bearable to watch, because the brain kind of needs some consistency to kind of process the data. So you don't want too much jitter with your animation, and that's why we struggle for high frame rates with 2D animation, with smears, with things like that. So what you could do is, like, for example, with this texture, this black and white texture, I could turn that into an image sequence, and it would make it start to look really trippy. Great, awesome. But in this particular production, I've decided to, whatever brushstrokes that I have is based on the distance change and the camera angle, so that it will start jittering a little bit based on the grunge that I have in my preprocessor.
Okay. Cool.
But yes, I could technically change this texture as an image sequence and it will start to animate. No problem. So yes, you can do that, but as a stylistic choice, I decide not to.
Well, nothing. Just kind of baffled by the complexity of this all, but it's quite amazing, really.
All right, do you guys want to know the next thing called the preprocessor?
Yeah.
We want to know
The camera
all.
box. Name it the camera box.
All right, yes, the camera box. So this camera box is basically, it contains a canvas. This is my canvas. And if I look through the canvas, it starts changing everything. Yeah?
That's crazy, dude.
It's just so much, but it's really good.
All right.
I can't believe you
So-
made a camera box.
So the reason why I made the camera box is because I need light on the canvas intentionally. If I go into the camera view and just make sure I switch out of the camera view for a moment, and I, for example, want to like cast a shadow onto the canvas like this, maybe even move this up a little bit more, kind of artistically like throw half the canvas into a shadow, or even change the color of this light. For example, let's just change this light into something green and go into the camera. I can now affect the canvas based on whatever I want. So I've kind of like disconnected the canvas lighting from the painting. And also I've created a system to basically, I can control different layers of different things. So the background is also disconnected from his face, so that I can control, the face. So this is basically compositing, but in Eevee, using a hack. And the basic hack is this. So let me go full screen and I'll show you. The basic hack is this. You take geometry incoming, then you take a refraction BSDF with an IOR of 2 or roughness 0, and then you use the shader to RGB node to create color data onto your plane. If I take a look at this, let me just recompile. It's going to see everything that's in the scene as it is, right? It's looking right through the thing and you can see the background. So I can the object is now transparent and it's seeing everything behind the object. Yeah, that's the foundation of the preprocessor. Before what the camera sees, something happens. It's kind of like post-processing, but Blender doesn't have that, as you can see. So it's kind of a hack. But this is the basic foundation that gives you RGB data to start manipulating. So let's go
Well, refraction in EV is a post-processing effect.
back. Yeah, crazy. I just call it preprocessor just for the logic, but yes, it is a post-process.
Wait, doesn't EB actually include refraction though?
Yes, it does. That is the
It does.
refraction. So you got to go to here, screen space
And
reflections,
enable it.
turn on refraction.
Then you have to go to material settings and enable it down there. And you
Not
can
nec-
determine the refraction depth.
screen space refraction.
Yeah.
And also another thing is turn off edge fading. Like, it's not necessary to have it on, just turn it off, so that you don't get these dark edges around the edge of the screen. So let me just turn it on to show you. Oh, you can't see it. Alright, doesn't matter.
No, I can see it a little bit.
There you go. So it's a problem. So back to the shader. So you take the original image and you start to do some stuff. So for example, I have another layer here with some scratches, a scratchiness roughness thing. So if I click on that, let it compile, take a look. This is my scratchy roughness. So this scratchy roughness is basically another texture that I've designed to be triplanar in the world space. So that if I rotate, whoops, let's just freeze the camera. Rotate around the world, these brush strokes change the angle based on where the camera is. So this is my jittering that I want. This is kind of like the global jittering that I want, which is less on the actual object and more about the actual window of the canvas. So as you can see, it's kind of jittering a little bit, and that's what I wanted. I don't want it to be so strong though. So go back to the texture. Whoops, that's not the texture. Preprocessor. Let's just freeze that. So I have 3 layers. I have the spickles layer, which is like a spickles texture here. And then I have my brushstroke layers here, which is based on world space camera, which is a null mapped by an attribute. Here it is. I have one texture here, the other texture here. One is the UV of the actual object, and the other one is the object mapping from the world space. I might change this to triplanar later. And I use that as a mask. And this mask goes into the roughness of my scratches. And then in my speckles, I use another texture, which is this one here, the speckles down here, based on a musgrave, or 2 musgraves, based on the generated UV and the general UV of the object to create some speckles. So let's take a look at the speckles. Now it's compiling. Here are the speckles, the paint speckles. So,
this is incredible.
So now you have the paint speckles. The speckles kind of helps me hide the fact that everything's a Fresnel. kind of makes the brush a lot more erratic and interesting, strong, powerful strokes. That's the art style that I wanted. And so if I rotate around, whoops, let's lock the camera again. If I rotate around, it's kind of, with the speckles, I'm kind of breaking up the edge even more with the color of the roughness of the preprocessor. So now let's mix and match. But as you can see, there's a problem. Everything is blurry, right? Everything. So what happens when you typically are an artist, you paint more detail on some things than others, right? So this is where we start to go into something else called geometry nodes. And things get a little bit more complex. So as you can see, I have a mask, a dynamic mask. If I select the object and I rotate around it, it's creating this dynamic mask of everything onto a grid. This dynamic mask is called ray casting. And let's take a look at my raycast system. Would you guys like to take a look at that?
Yeah. I want to see that whole man-made horrors beyond my comprehension.
Alright, so let's take a look at my preprocessor plane. It has a geometry node tree, so let's switch to nodes. Select the thing, here it is. Go to my modifier stack, select geometry nodes. This is the legacy version, geometry nodes 3.0, or the old version of geometry nodes. So the new version is going to be different, but the theory is the same. If I take a closer look, I have an attribute called direction, and I have an attribute called position, and I have an attribute called level 1, which is the layers, right? Layer 1, level 1, level 2, layer 2, level 3, layer 3. So at the beginning, the first things first, you need to set the camera direction or get the camera direction, which means you take the camera's relative position or location and you subtract the vector from the geometry that you're looking at. So you have the camera point and the geometry point, and that creates a direction. You subtract it one from the other. That's basically it, the subtract mode. Then you use this as the geometry direction to raycast from. You use that as the direction. Then you cast a raycast from a collection. So you get the collection data, for example, my hero layer, and you use the hero layer to drive the rays. So it shoots the rays from the camera to the geometry from the collection as the target geometry of what it's hitting. And when it hits the target geometry on that plane, I tell it to convert the attribute onto a vertex color, face corner color group. So this face corner color, this is a vertex color group. So if we take a look here in the vertex colors, we have layer 1, layer 2, layer 3. So I write this information into the vertex colors, and then when I go into the shaders, they're in the shader, I can tell Eevee to get the colors from that particular layer, and I use that as a mask. Make sense?
That's just...
So if we take a look at the mask again and go back into the 3D mode, that's how we can create a mask. So notice that, okay, so we have the camera here, and we have the geometry here. This creates the direction of the rays of that particular thing. And then we have this collection, which is the character over here. He's that collection that is causing the yes, I got hit, and the no, I got hit attribute concept. So as you can see, the resolution is based on the density of the mesh. I'm just keeping it relatively low for performance reasons now, but on render time it's higher. And that creates my dynamic mask so that I can decouple how blurry the background is from the hero asset. So all together now, if we take a closer look into the camera and let it compile, now I can have two separate layers of, let me just close this. Two layers which I can define how strong or how sharp I have the actual hero asset based on the processing. Get some nice style. Hello, Amin. Nice to see you here. And also, Slink says terrain nodes are really cool. I also agree. I need to play with that. So that's the preprocessor, basically. I use some grunge nodes. I have some color tint nodes. I have a color correction nodes. And then I also have the paper texture. I have a mask for the paper texture, which I need to change. That's why it's in red. It's going to be replaced. And then I use my roughness system, and which is unplugged at the moment. Actually, I should work that. It's not finished. And then I use the normals, where I'm masking the paint bump normals with the mask, with the paper normals. And on top of that, I'm also getting the same refraction to create a blurry bump with some math, I guess you could say, to kind of add that paint texture. So if we select everything and just go let it compile. Also drop that in. So here it is compiling. As you can see, if I take a closer look at the canvas, let's go to the bottom corner here and let it hold. You can see that the paint is flatter than the texture of the canvas. But in some areas, sometimes the paint is thicker than others. So where it's black, it's less thick. Where it's light, it's more thick. So that's a bump that I needed. Also, if I go to, like, for example, here up here in the light, if you can zoom in a little bit. Can you see the wobbliness here going along of the paint thickness? I wanted that I wanted this to be textured from the image, but Eevee's multi-sampling system is not good for this. So the bump textures, lots of tiny microdots made from general warped blurriness. But this gives me a kind of like an okay undulation of the paint, I guess. Not the best, but that's why I prefer, for example, I decided to keep the bumpiness inside the actual material here. So here's the character. You can actually see the paint texture from the actual material instead of the preprocessor to kind of get that vibe. So those are the elements. The preprocessor is kind of like a hacky way to use RGB, red, green, and blue values to create some compositing. The light box for the canvas, the material with the 4 pillars, which is the coherent scale, the broken up normals and shadow Terminator, the colors based on that, and the Fresnel based brush breakup, and then using like the different types of canvas post processing, I guess you could say, for whatever you want. And that helps me create this painterly effect without needing to render directly in the viewport. Make sense?
Yes.
Is that a joke?
So much.
That's crazy. Jeez.
Okay, I'm trying to replicate or try to do raycasting with the geometry nodes for the first time ever, but I can't find a node.
Yeah, I'll tell you what. I can walk you through it nice and quickly. And I'll do it with the new geometry nodes, yeah? So load up.
I'm using 2.93.
Ah, okay. Okay, so that is the same system. Um, 2.93. I recommend you start to use 3.0 or 3.1, mainly because it's more stable than 2.93 and it has more features. And also geometry nodes is the future. So the system you're learning with 2.93 is currently now legacy, means it's no longer going to be supported.
Oh. Okay, let me just launch Blender for Artists then, because I also have it installed.
Oh, really?
It's the latest version now.
Yeah, latest div build. Alright, so I'm going to make a grid. I think I have a camera here. Yep, the camera's here. I'm going to move the grid full screen so you can see what I'm doing. I'm going to put the grid, copy it, copy the location, and copy the rotation of the camera. Move local, move it up a little bit, make it smaller. So this is my preprocessor grid. That's basically it. I'm going to parent it to the camera. This is what you first need to do. And I'm going to create in a new collection. I'm going to call this the layer collection, and I'm going to add a donut.
Okay, so if I heard right, create a no, a grid, yes.
Mm-hmm.
when you refer to grid, oh, okay, it's an actual object in here compared to Mindmaps. So scale twice, add a camera. Okay, move it up a little bit. Alt R to remove that. So to make the camera track to make the camera track to the plane, does that also work, or can I make it track to an object, like make it track to the donut?
If you want, yeah, you can like make a point to the donut all the time. But in this case, I like to have like a free camera, you know, and I just parent the plane, the grid, to the camera. That's the first thing first, all right? So the next thing we want is basically select the grid, go to geometry nodes, click new tree. Now we have a new tree on the grid. And in the new tree, we'll go, let's go full screen. And let's go icon buttons. Zoom in a little bit so you guys can see. So we want to get input object info. So we get object info and we select the camera. Great, that's all we need. So now we need to get the position. I think it's called position. And we need a math node, a vector math node. So with the subtract, we get the position here, subtract, and then the location here into the other one, and we subtract one to the other. This is our direction. Now we're going to search for geometry raycast. So in the geometry raycast, I'm going to plug this in like this. Just unplug the end. And in the geometry raycast, we would put the ray direction into the subtract node. I think that's what you would do. But I'm not entirely clear. I think I have this other scene I saved elsewhere. We just quickly save this to confirm. Study group.
Subtract.
Geometry nodes. We'll call this raycast 3.0. Save. Let me just load up my... Maybe it's easier if I have it already set up so I don't give you bad information. Themes, geometry nodes. Distribution, geonodes, enjoy energy. Oh, sorry. Library, scenes, geometry nodes, or geometry. Raycast scattering with height threshold. Perfect. This will give you an idea.
I appear to have come to a problem. I don't have the position node.
Okay.
You are not using 3.0 then.
I'm using the...
Okay, it's not necessary.
this,
Actually,
like...
it's not necessary.
Ah, okay.
Are you using the dev build or are you using 2.93?
The one that the 2.93, the official release, because I didn't want to deal with instability, but you just told me that it's far more stable, so I'd have to download it.
Okay, yeah, because that version is actually the based on blended 2.93.
Okay.
Here it is here's the meat and potatoes for the Raycaster. It's much simpler than I was expecting, sorry.
So collision info. Collection info.
But
Okay,
actually, I
then.
don't remember how to... I think we have to use an attribute convert. Attribute capture. Attribute transfer. Attribute transfer. We need vector. We get Vector. I'm still learning 3.0, so it might be a bit more difficult. Face corner, there we go. Face corner, color, perfect. Capture the, oh, there's capture. How do we set attribute? Attribute statistics, special characters, materials, transfer attribute. Color. Nearest face interpolated. Source position. Okay guys, well, it has been nearly a whole hour. But the general concept is the old system is probably going to be easier in this case, but here you have the collision group, which is your target geometry of the things you want to hit. So you have your collection info. I just realized those instances of everything inside the collection by joining the geometry together, so it's like one mesh. Might not be performant, but I needed this as real instances, so I have target geometry for collision. Then I have this ray direction. The ray direction is where you take the camera position and the position of the object, which I think we don't have the current get position. I'm not sure yet. I'll have to find you out later. And you use the subtract to get the direction. And then from there you have this option called hit position or the hit normal and is hit. When you use the is hit, we can eventually, I'll have to learn this for you later, but theoretically I should be able to capture that and transfer that attribute as a color value onto a vertex color. But the system is completely different in 3.0 than it is in the other systems, because here, for example, with this example, I'm taking the ray cast inside the box with a certain height to scatter these cones based on what they hit at certain levels of height. So I can have some kind of like a collision system. But this is the same technique where you ray cast and you just write that information into the geometry vertex colors. That's basically what it is. But I need to learn how to do that first. The basic foundations of like, okay, so how do I read and write from Blender data? You know, vertex groups, UV groups, you know, how do I do that? Still don't know. Because they changed everything. For good.
Yeah, fields is just way too different.
It's different, but when you learn it, it's easier. So, but the problem is you learned another system and now you have to learn a different system. So it's a little bit more slow.
The woes of open source software.
Yeah. Alright, so I just hope you guys found that interesting. We didn't do a lot of character exploration at the end of the day. But I hope you guys learned something from the Painterly summary from all the past couple of weeks, and I hope you found it interesting.
We just
Fuck it,
crashed this
upload the
entire
shader.
party.
Huh?
We're just gonna crash this party.
No, it's good, it's good.
Nah, fuck it, Trace. Upload the shader now.
It's not finished. I want to make an animation first.
Upload it now.
300 million.
The shader is in beta. You can finish it later.
300 million, take it or leave it.
300 million?
Yeah.
Is that an offer?
I mean, is it?
Oh man, sounds good. I guess now it's just I need to... the reason why I did this Painterly, partially, was because I wanted everything to be super low poly. So for example, I could decimate this without a problem and it would still look okay. For example, this here is way too high poly.
Way too high, yeah.
So I could just
yellow.
decimate it like crazy. Turn on wireframe so I can see. Start collapsing. And it should still look okay. Boom. Same with this and this. Decimate. Drop it down to here. Not to be a single triangle, but you know, apply that. We'll go back to the scene and turn on the shaders. It looks pretty much the same, and I just saved myself some resources. Back into my preprocessor, yeah, it looks the same.
That is incredibly intelligent.
And the
How
same.
long does it take to render one image?
Yes.
It's Eevee, so it should be not too
3, 1,000, 4, 1,000, 5, 1,000, 6, 1,000, 8, 1,000, 9, 1,000, and 1,000.
It should be a couple
The
of.
screen sharing is probably taking its toll.
It's also only have a 1060, yeah, a GTX 1060.
Oh, dang.
This is really performant, considering that. Very,
Nah, his GPU
congratulations.
just sucks.
Yeah, mine's terrible. My graphics is terrible. But it should be under a minute. Hang on. I haven't actually done this test in a while.
Next thing you
Under a
gotta make a
minute.
shader to fix,
There we
fix
go.
the Blender
It
viewport
took
performance.
49 seconds on my 1060.
Okay.
But that's
10
with
more
everything.
reasons why Eevee is bad.
24.5 frames per second for what, 2-minute video? Which would that be?
So let's just do some math here. So here we have 50 seconds per frame by, say, I'm using 24. So that's 12,000 seconds divided into 60. That's 20 minutes per second of animation on my 1060. So
Kind of heavy.
if I have a full minute of animation that's in minutes divided into 60. That's 20 hours of rendering.
20 hours for 1 minute.
So that means I could render the whole thing in 1 week. It's a 6-minute video. So
Epic.
yeah, I could render this in 1 week. Or 2 weeks overnight. 10 hours a night.
Will you be releasing this shader?
After I finish the video, I plan to finish the video by March next year.
Okay.
Because I still need to stress test it, yeah? You know, I need volumetrics, I need to know, like, okay, how am I going to paint metals? I still need to, like...
Let the users decide.
I release unto you fire. Use it for war or food. It's up to you.
But yeah. So I won't keep you guys waiting. Thanks for hanging out for the stream. I will be connecting here again next week. Same time, same place. Possibly to continue doing character design and also showing an actual animation test. Hopefully I can get some renders by Saturday. But, you know, crunch be crunch. We'll see how it goes.
Very
So-
awesome.
Thank you so much.
Very
Yeah,
well.
Thanks for the questions and for the talking as well. I really appreciated this live dynamic. I hope you guys can connect next week, actually. So
Yes,
feel
we will.
free.
I'll definitely be here.
Yep.
Excellent.
All right. Thank you.
See ya. Have a good day.
Thank you so much.
Yeah. Bye bye.
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 Have a good lunch.